Good morning.
Good morning. Good morning. How's it going? Good morning, everyone. Good morning. Hope all is well. Hope everybody's all right. Oh, still got a few trying to connect. Let's give them a chance. All right. Looks like everybody is in. So once again, good morning. Hope all is well. Hope everybody's doing all right. I sent you guys an email because I've been talking to the Math Lab rep, and I need your purchase status. You'll see it in the email. It's one of three situations. Either you have purchased MathLab already, or well, first of all, either you haven't purchased anything yet, you purchased MathLab, or you purchased MathLab and Connect Math. Well, I guess it could be four if you purchase Connect Math, but not MathLab. So whatever your situation is, let me know. If you purchase Connect Math, you purchase Connect Math and MathLab, you could purchase MathLab already, or you haven't purchased anything. And please respond to that thread. I got somebody else coming in. I have to say it again. So for a second, we get in here. But yeah, so please respond to that thread so I can have a centralized place where I can respond to you guys about the same situation, because I have a whole bunch of emails coming in from different classes and everything like that. So yeah, even if you said something to me before about your status, I got some information to send you guys as far as the class is concerned. And I just, so it'd be easier if I just had this one thread that I'm just shooting all the same information to. So I sent an email, earlier this morning. So, at your earliest convenience, please respond to that so we can try to get this stuff straight for those who need to try to get a refund, try to get that happening, so just need you guys to respond to that. Any questions? Everybody good? All right, so we are looking at, just want to make sure I got my sections straight. Give me 1 second. Nope, I hit the wrong button. So last class we did 3, 3, 4, 8, 5, 6. Looking at 9, 5, and 9, 6 today. Okay. All right, so we're looking at 9, 5, and 9, 6 today. Here's my, this 130. All right, so in 9, 5, it discusses solving for specified variables. So whenever we're solving for a specified variable, our goal is to get that variable alone by itself. So on the other side of the equation, more than likely you won't have a solid number like we had before. Last class we had like x equal to 3, x equal to 2, or something of that nature. So in this case, we will have a variable on one side, the one we're solving for, and then an expression on the other side. So what do we mean by that? If we look at this first problem, d equal to r times t, and we want to solve it for t. Each one of these variables represent a number. So we're going to treat them like numbers. And so what I mean by that is if I had 5 equal to 3t, and I wanted to solve for t, I would divide both sides by 3. 3's cancel, and then my result would be t is equal to 5/3. So we follow that same process, thought process, that same pattern. I have r times t on the right side, and I want to get t by itself. So what I should do is divide both sides by r. R cancels, and so that means t will be equal to d over r. All right. Make sure we're okay with that before we go to the next one. All right, everybody good?
Hey, Professor, I have a
Yep.
question. Okay,
Yep.
so you said T is equal to D over R. So why wouldn't it be D is equal to just T, because R cancels out?
But it doesn't cancel out on this side.
Gotcha.
Yep.
Okay, gotcha.
Yeah. So I'm glad you said that. So making sure everybody's clear on that. So it canceled out over here, but it did not cancel out over here. So that D over R is what's left over in that expression. Good question. Good question. All right. Anybody else before we go to the next one? All right. So, and then when just want to point out, when you look at the title for the section, if you were to go to the book, it says formulas and problem solving, but we're not, I don't, you guys didn't have any problems, like word problems in this section that they held you accountable for. If you do see something in your homework, let me know, but I know last class, they didn't have any word problems in there, so you're good on that front. All right, so let's look at the next one here. Y equal to mx plus b, and we want to solve for x. So that means your goal is to get x by itself. All right. So once again, we want to treat this the same way we would treat this as if we had all numbers and just one variable. So if I look at this, if I had 10 equal to 2x plus 5, remember we said the first move we would make is to subtract 5 from both sides, the number that's not attached to your variable that you're trying to solve for. So we're going to do the same thing here. I have mx plus b on the right. I want to solve for x, but the first thing I will move is the b. So I'll subtract b from both sides. B's cancel out on the right. And that leaves me with this expression right here, y minus b equal to m times x, or mx. All right. So you cannot subtract y from b, because you don't know what they are. They're not like terms, so you would just leave it as y minus b. All right. Then from there, we would have that, and we would, since we have m times x, we're going to divide both sides by m. The m cancels on the right, and that leaves us with y minus b over m as our final expression. X is equal to y minus b over m. Any questions? All right. Everybody good? Go to the next one. All right, so the next one we have P equal to 2L plus 2W, and we want to solve for L. We want to get L by itself. All right, so just like before, you know, right here, you know, it's leaning on when we have numbers, leaning on the thought process when we have numbers. This number over here is what we move first. And so the same thing is going on here. I'm trying to solve for L, so I'm going to need to move this 2W first. So I will subtract 2W from both sides. 2W minus 2W cancels on the right. So then on the left, I have P minus 2W. And on the right of the equal sign, I have 2L. So, any problems with that before we go to the next step? All right. So now 2L, so I have a 2 in front of L. I will divide both sides by 2. 2's cancel on the right, leaving me with P minus 2W over 2 as my final expression. So before we do anything with that, because I'm going to show you how you can reduce that, why you don't have to reduce that, the wrong way to reduce that, but making sure we're okay getting right here. All right. Okay. So there are a couple ways we can handle this. Now, we have P minus 2W over 2. You can leave the answer like that. You don't have to go any further because this 2 cannot divide evenly into both of these term and numerator. Like you cannot take 2 into P evenly. But, and I'll show you what I mean in a second. But if you just wanted to reduce, the incorrect way of doing it is this right here. You cannot just cancel out the 2 in one term and be left with P minus W. So that is the incorrect way. The correct way of doing it is taking the 2, you know, we're down here, taking that 2 in the denominator into both numerators. Whenever you have a denominator, it has to go into each term that's in your numerator. So that's what we did right here. You have P minus 2W over 2. That 2 goes into each. So now you're looking at P over 2 minus 2W over 2. After that, then you can cancel out those 2's. But notice you still have 2 in your denominator left because 2 could not divide into P evenly. So that would be the correct way to reduce if you wanted to reduce. Once again, you did not have to do that because that 2, notice right here, 2 could not divide into P. So you didn't have to move any further. That's what I said right here in the purple. This answer is fine because the 2 cannot divide evenly into each term. So, you know, and I'll show you an example of what that means if we did have that. But if I had a number sitting out here like 4, if there was a 4 in front of the P, 2 could divide into 4, that's something you are expected to reduce. But once again, this was okay to leave the way it was, P minus 2W over 2, because the P didn't have a number that the 2 could divide into evenly. All right. Questions on anything I said right there? Make sure we're okay.
Yes, I have a question.
Mm-hmm.
So if P minus 2W divided by 2 was fine, just wondering, why would someone simplify it even more?
Because they saw 2's right here.
Okay.
That's it. Yeah, nothing will tell you to go past this point. Now, they are going to tell you to simplify as much as possible or expect you to simplify the expression as much as possible. So you may be in that mode thinking like, okay, what else can I simplify? How can I write this in lowest terms? Which is where you should be thinking. But I just didn't want someone to think erroneously and think, okay, since I see these 2's right here, I can cancel those 2's out and be good to go. And so I just want you to reduce properly and not do it incorrectly, because you would have, this is the right answer, but if you keep going and write this, then you got the wrong answer. You know what I mean? So, yeah, so I don't want anybody to get something wrong that they didn't have to get wrong.
Okay.
Yeah.
Can you scroll up a little bit?
Let me know when to start. Oh, do it like this. I don't know what a little bit is.
Thank you.
Are you good to go?
Yep, I just took a picture.
Okay, cool. All right. So, and then I just wanted to show you here, if we had the 4. Oh, I had my eraser still on. Hold on. So, like I mentioned, if I did have a 4 in there, how it would look. So, once again, that's just an abstract example. There is no 4 in our problem. I'm just showing an example is if you did have a 4 in front of that P, what you would be expected to do. So that 2 in the denominator has to go into each numerator. 4P over 2 minus 2W over 2. Now divide the 2 into each number. That'll leave you with 2P minus W. And so in the purple you see right there, it says you must simplify because 2 can divide into each term evenly. So once again, I just want to make sure we have clarity. This is a random, I'm just pulling an example out of the air just to show you what it would look like if you had to reduce. It has nothing to do with the previous problem. I just want to show you that and what you would be expected to do if you had that scenario. Any problems, questions, or concerns? Anybody first day today? Anybody who's curious? Everybody who was here last class? Okay, cool. All right, so the next one. We have V equal to L times W times H, and we want to solve for W. So we can kind of do this one in one step. Once again, all of this is multiplication, L times W times H. So I want to get W by itself. I'm going to get that W on one side by itself. So I can divide both sides by LH. Because all of that is multiplication. So the L's cancel, H's cancel, and that leaves me with W equal to V over LH. All right, any problems, any problems? So that's pretty much what you're responsible for in 9.5. So make sure you try them out. If you get stuck on anything, always feel free to bring it to class and we can discuss it. Remember, every day is an opportunity for questions. Shoot, we got 2 hours set aside, so we can, we're gonna have time to ask questions. Like I told you before, I'm not gonna talk for a whole 2 hours. But yeah, try the stuff out. You got the weekend, try some of this stuff out, see if you get stuck on any problems, and we'll take care of them. Any questions before we go to 9.6? All right, I think I wrote a note to myself. So we'll go to notes for inequalities, 9.6, 4 point, yeah. All right, so section was 4.7 in our, if we were using Connect Math, it would be section 4.7, but it's going to be 9.6 for solving inequalities. So make sure, yep. All right, so 9.64 is solving inequalities. Oh, let me make sure I'm not missing anything. See, somebody said something. Oh, okay, I was just trying to make sure none of the classmates were trying to get in while you guys are looking at that. Okay, all right. So a linear equation is what we've dealt with up to this point. An example of that is 2x plus 5 equal to 7. A linear inequality is what we're going to use or deal with in this section. Example of that is 2x plus 5 is greater than 7. So the main difference between the two, first difference between the two, is that an equation has the equal sign. The inequality, an inequality will have an inequality symbol. So you notice in our linear equation, we have that equal sign. That's why I have the gray arrow pointing at that. Then we have the greater than symbol, which is an inequality symbol. That's in our inequality. So now the next thing that we have to recognize, noticing that we have an equation versus the inequality. In an equation, you will get, well, in a linear equation, you will get one solution. So our solution will be x is equal to 1. In an inequality, you will have infinitely many solutions. You will have what we call a solution set. So notice in blue, we're talking about x is greater than 1. So that means all values greater than 1 will be solutions or are solutions. And then also in this case, 1 is not a solution because we're talking about all the values that are greater than 1. You know, so all values 1.5 would be 1, 100 would be 1, 1 million would be 1, 1.00001 would be a solution, you know, because it's greater than 1. So all values that are greater than 1, and that will be your solution set. Questions on anything I've written on the screen so far? Make sure we're okay. So the equations that you dealt with up to this point, you were getting one solution. Now you're going to have infinitely many solutions. You're going to have a solution set when you solve. All right. So the way we would solve this equation will be the same way that we would solve our way we would solve this inequality, excuse me, would be the same way that we solved our equations. Wherein if I had 2x plus 5, let me erase that. 2x plus 5 is greater than 7. Then the first thing I would do is subtract 5 from both sides. 5's cancel. That leaves me with 2x is greater than 2 because I have 7 minus 5 on the right. And then I would divide both sides by 2. 2's cancel and x is greater than 1. And that's your solution set for that inequality. So it's the same process. We have one step, one extra thing that we do have to be concerned about when solving inequalities. We'll talk about that in a second. But it's the same thought process that you will have. All right. We have these extra symbols that we're dealing with, but it's the same thought process when it comes to solving. All right. Very good. Of course, if I scroll up and you still copy, let me know. All right. So here are our 4 inequality symbols that we'll be using. So we have less than, equal to, greater than, equal to. So the difference, you know, you have that bar under it that lets you know we use it, saying or equal to. You know, if you use that, then it means you actually include that number. So before when we had x is greater than 1, 1 is not a part of the solution set. But if we had said x is greater than or equal to 1, now 1 is a part of the solution set. So it's telling you, just give you a heads up as to how you should be thinking when you see these symbols. And so right here in red just reiterates what I just said. So if I have x is greater than 2, all values that are greater than 2 will be your solution set. 2 is not a part of the solution set. So we're just talking about values that are greater than 2. But then if it says greater than, or if we use the symbol greater than or equal to 2, we're looking at using 2 as a part of your solution set. So that's why I said down there, 2 is a part of the solution set if you have that bar under your greater than symbol. Any questions? Any questions? Make sure we're okay. Scroll up. Everybody good? All right. So the other part of what we'll be doing, we'll have like 3 pieces to our answers. We'll have interval notation. I'm going to show you a chart that has it all in there. So we're going to have the solution set, which is what we just finished talking about. We're going to do interval notation, which is what we're about to talk about now, and we'll do a little mini graph, which will, all pieces will reflect each other. So if you only had one piece, then by the symbolism, you know what the other pieces will be, and so on. So for less than and greater than symbols, we would use parentheses, and that means exclude the value, and that goes back to what we're saying up here. If I have the if I have greater than, I'm not including the number 2. And so the parentheses just reinforces that. Less than or equal to, greater than equal to, I've used bracket. That means I'm going to include the value. That's what goes on right here. 2 is included as a part of the solution set. So they just reflect the same meanings. And then we have our negative infinity and positive infinity, and we will always use parentheses on our infinity signs. Always use parentheses on our infinity signs, because you can never include infinity. You can always go to that next number. Once again, you can never include infinity. All right. So using that as an example, here are some examples, I should say, of using those symbols. If we have x is greater than 2, then if we look at number line, we would be going from 2 to infinity, and we will use parentheses on both. Remember, for your infinity signs, you're always using parentheses. And because I do not have the or equal to symbol here, I'm going to use infinity, not infinity, but parentheses on the 2. Now, if I have the or equal to symbol, then I will use a bracket on the 2. But notice right here, I'm still going to use parentheses on my infinity sign. So remember, this represents all values greater than 2. Talking about 2 to infinity. Any questions? Any questions? All right. So like I said, the next piece that we will be looking to implement as a part of one of our solutions. So in my math lab, they may ask you for 1, they may ask you for 2 of them. They may ask you for all 3, but either way, you should be prepared to give all 3. So you're talking about x is greater than 2. Once again, that reflects 2 to infinity. And you use the same symbolism that you use up here. So notice you have parentheses over the 2, and then you shade all the way to that right arrow, which means or implies infinity. And then for the next one, greater than or equal to 2, you use a bracket over 2. Same shading though, you're still shading all the way to the right to represent positive infinity, but you're using a bracket over the 2 because you have the or equal to sign. All right, questions, any questions? All right, scroll up. All right, so this green statement is a part of the chart. It says A and B are real numbers. So A and B represent numbers in this chart. And so just giving you a generic way of looking at what you would shade, what symbols you use, how you would shade and all that. All these scenarios that you could come across. So X greater than A, X greater than or equal to A, that's basically what we did here with the 2's. So that's just a part of our chart, first part of our chart. So if your solution set ended up being X is greater than A, we would do parentheses A comma infinity, and close it out with parentheses. Oh no. There we go. And then shade to the right. Write your A down, put parentheses over your A, and shade to the right. The next line, same thing, it's just that we're using bracket over the A instead of parentheses. The next 2 deals with less than. So notice the positioning of the infinity sign. So make sure you're careful with that. We always read from left to right. If you, excuse me, if you were to look at your number line, negative infinity is all the way to your left. So it's negative infinity up to your number. So that's why we have negative infinity, comma, A right here for interval notation. So you're always reading from left to right. We did A to infinity. Negative infinity comes first, and it comes up to whatever your number is. So that's negative infinity, comma, A. And because we just have the less than symbol, you use parentheses over A. The next one, that fourth row, is the same shading. It's just they use bracket over the A instead of parentheses. All right, any problems so far or questions? Next 4, in the charts, if you have a 3-part inequality, so you have X in the middle, your variables in the middle, have your 2 numbers on the outside. That says that your solution is going to be everything greater than A but less than B. So all the values in between A and B. So our symbols are less than, so those parentheses over the A and B. And then we shade in between A and B, once again using parentheses over A and B. This second one, notice we have the or equal to symbol attached to A. So that means we use bracket on A, but still parentheses on B. Same thing reflects in your graph. Third one right here, now we have the or equal to sign on B, so the bracket is over the B, still shading in between. And then on the last one, we have the or equal to symbol for both of them, so that means brackets over A and B, and once again shading in between. All right, any questions?
Hey, Professor, is there any
Yep.
way you can actually send us a screenshot of this chart via email or scan it or something, or send it to us via email, or well, send it to me. I don't know about nobody else, but
I'll see what I can do. Shoot me an email to remind me to do something like that. Yep.
okay, cool.
Mm-hmm. Yep. Because I'm pretty sure I probably forget. Yeah, it's easy, man, especially right now. I don't know what. Maybe it's just because I think this is the first summer. Yeah, this is the first. No, we did do it last summer. I don't know, man. For some reason, this summer I've got flooded with emails ever since Saturday. It's just like wow. But yeah, I don't know why it is. So yeah, I'm pretty sure with all the emails I got to respond to, probably gonna forget that since it's not a part of my normal routine. So as soon as you shoot me that email, that'll like give me like this marker reminder to respond to that, and I'll shoot you one. All right. So let's look at solving these inequalities. So once again, I said that we're going to be solving these inequalities the same way that we solved our equations, but there's one thing that we have to consider and keep in mind when we do so, and that's this statement right here. When solving inequalities, you have to multiply. When solving inequalities and you have to multiply or divide by a negative number, then you must change, or some people like to say flip, the inequality symbol. So in other words, if it's greater than, if you divide by a negative number, you have to flip, change it to less than. All right, so if I have negative 3x is greater than 5, in order to solve for x, I would divide both sides by negative 3. And doing so, when you divide both sides by a negative number, that means you change the inequality to the opposite. So if it was greater than, you change it to less than. Or if it was less than, you change it to greater than. That's the only thing you have to remember that's different than when you're solving your regular equations. Oh, right here, then I went ahead and did the solution set and what interval notation and the graph. This right here is your solution set. Then we have our graph down here. So we're talking about all the values that are less than negative 5/3, because it's just less than, not less than or equal to, put parentheses over the negative 5/3, and we shade to the left. Remember, to the left is always less than, left, less than. You think about L's. Greater than will be always shading to the right. And then your interval notation right here. That's negative infinity to negative 5/3, using parentheses over both. Infinity signs will always carry parentheses. Oh, this is nice. All right, any questions before we solve a few?
So when we, hold on, so when we graph because when you read it, it says our final answer is that x is less than negative 5/3, right?
Mm-hmm.
So when we're graphing x being less than, I think I'm overthinking
Oh, it's possible. It's possible.
it. Because I think I just need to go over this in my head. Never mind.
You sure? Sure, there's nothing I can say?
Yeah, I don't think so.
All right, whatever you think about something, let me know. All right. All right, so if we have, let's
Hey,
look at,
Professor. So all right, so I
yes.
want to chime in on what she said. So why
Okay.
is it the solution x is less than.
You said, why isn't it?
I said, why is it? Why is it x is less than?
Okay, now let me make sure I understand what you said. Why is it? Now, this right here, when you say x is less than -5/3, what it's saying is that anything less than -5/3 will make this a true statement. So when I plug in a value for x, now our statement right here is, this statement right here says that -3x is greater than 5. So as far as my solutions, I want to plug in values that will make that statement true. So if you're talking about -3x, that left side, basically saying left side is greater than right side. So I need to plug in values for x that will make my left side greater than my right side. If I plug in just any old thing, it may not give me a true statement. So in other words, if I plug in 2 right here, that's going to be -3 times 2, which is -6, and -6 is not greater than 5. So I can't just plug in any old thing. So now we're talking about, this says my solution set is going to be anything that's less than -5/3. So let's plug in -1. If I plug in -1, that's -3 times -1. I'm just plugging in anything. That's going to be 3 is greater than 5, which is still not correct. So I need to make sure I know what the decimal value is for that -5/3 in order to be as accurate as possible. So you're talking about 1.6, so -1.6. So I need something less than -1.6. So let's try -2, right? So if I put -2 right there, -3 times -2 is +6. Now I have a true statement.
Okay, gotcha.
6 is greater than 5. So that means anything less than -1.67, you know, if you go infinity decimals, but -1.6 will give me a true statement.
Okay, cool. Got it.
All right. Anything else before we look at solving another one? All right. So we have 5x minus 6 is greater than 4x plus 2. Same thought process as if that was an equal sign. I need to get all of my terms with x to one side of my equation, all of my terms without x to the other side. Doesn't matter which one you decide to move first. I'm going to subtract 4x from both sides. And that cancels for me on the right. On the left, I have 5x minus 4x, which is 1x. Minus 6 is greater than 2. Now I will add 6 to both sides. 6 is canceled on the left. And my solution set is x is greater than 8. So we have x is greater than 8. That means I'm going to shade to the right. So greater than is always shading to the right. If you look at the number line just generically, 0, 1, 2, got -1, -2. So anything that's greater than -1 will always be to the right of it. Anything less than -1 will always be to the left of it. Same thing with +2. Anything greater than +2 will always be to the right of it. Anything less than +2 will always be to the left of it. So that will always be the case. So if you're talking about greater than, we're shading to the right. If you're talking about less than, we're going to be shading to the left. So that will always be the case. So we have 8 greater, x is greater than 8. So we want the values that are greater than 8. We're shading to the right. We're going to use parentheses because it's just a greater than symbol. If it had the or equal to, then we use bracket, but it doesn't. So we're using parentheses. Then your interval notation reflects the same way. 8, comma, infinity, parentheses over both. All right, questions, any questions? All right, let's do another one. So if we have -5x minus 3 less than or equal to 12. All right, first move is to add 3. 3's cancel on the left. There's somebody out there. Then we have negative 5x less than or equal to 15. So we'll divide both sides by negative 5. Negative 5's cancel on the left. Don't forget, whenever you're dividing or multiplying by a negative value, you're going to change your inequality. And I think I want to make that another color. And so that's going to be x is greater than or equal to negative 3. Because like I said, we had to change our sign. We divided by a negative. All right. Shading to the right using bracket because we have that or equal to symbol. And it's negative 3 to infinity. All right. Any problems? Any problems? All right. Any problems before we look at a 3-part inequality? Make sure we're okay. All right. So 3-part inequality, last type of inequality that we'll be looking at in this section. Remember, your goal is to get your variable or keep your variable in the middle. You want to solve for your variable, get your variable by itself, but you want to leave it in the middle. So the way you would do that, let's say if we had, or we didn't have that part that's sitting in front, we had 2x plus 1 less than 7. Well, our first move would be is to subtract 1 from both sides. So you're going to keep that same thought process. It's just that subtracting 1 from both sides, you're going to subtract 1 from each part. So we have 3 parts here. That's why it's called a 3-part inequality. This part, and this part. So we're going to subtract 1 from each one of those pieces. So the 1's cancel in the middle. And that leaves us with negative 4 less than or equal to 2x, which is less than 6. Then still trying to get x by itself. So we'll divide both sides, or that's it, both sides. So used to saying both sides, each piece by 2. So that will cancel out the 2 in the middle. Then a negative 4 divided by 2 and 6 divided by 2, which would be negative 2 and 3 respectively. Once you get x by itself in the middle, you have solved the expression or solved the inequality. All right, and then your other 2 pieces to your answer. Interval notation, negative 2 comma 3, bracket over the negative 2, parentheses over the 3, and then shade in between for your graph using that same symbolism for the bracket over the negative 2, parentheses over the 3.
I have a question. Would you have to change the sign because it's a negative 2?
You would have had to change the sign if you had a negative that you were dividing by. You know, I don't think they're going to give y'all that because, but if you were to have it, if you had to divide both sides by negative 2, You know what I mean? Like if you had a negative that you were dividing by, then you would have had to change the signs.
Okay, thank you.
Yeah, not a problem. All right, anything else? Anybody else? Was there another type of problem anybody wanted to see? Are we good so far? Very good, very straight. All right. Okay, cool. So that is it for our first block of assignments or first block of information. Our first test, let me go here. So if you look at our first test and what you guys are responsible for in the first set of information, we have 3, 3, 4, 8, 5, 6, and we did that first class. Then we look at 9, 5, 9, 6. So that's our first block of information that you guys are responsible for that will lead into your first test. All right. So like I mentioned before, it's a 16-week course. We putting everything into 10 weeks. So then you see we have a whole hour. Yeah, a whole hour left in this class from 9 to 11. I'm not going to do anything else because I need you guys to go ahead and get in there, get your footing straight, and get into my math lab. And you see how quick this can move if you're not staying on top of things. I won't do anything else new today. We will be getting into chapter 10 next class, but I will open up the floor for questions first. So any questions that are generated through this weekend, over this weekend, doing work, doing assignments, I will, open up the floor for that and we can discuss that. But I just want to show you how, what assignments you're responsible for. The study plan will help you as a review. Same thing with this quiz. But if you were to click on this test, you notice how it asks you, I don't think you guys can see it. Let me go. So notice how it asks you for a password. So that password I do not just give to you. All of your tests have to be proctored. That's the way that these developmental shells are set up. So if you want to take a test, directions are right here. Let's say if you're just ready to take a test. jldavis@tcc.edu. That's Mr. Davis and Tutoring Center. You can CC me on that. If you do have an accommodation sheet, make sure you mention that. Let me see detail. You can mention that to them, but you most definitely want to make sure I see that so I can make the adjustments in my math lab. But this is how you would take care of any test. So the way they would do it, you don't have to go in. He'll give you scheduling for Zoom sessions and give you information as far as how you would log on and all the stuff like that. And then, yeah, you would just take your test for the time that you have set that up with him. And they'll go from there. Either he'll be sitting there or have one of his workers be sitting, making sure everything's straight. All right. Questions on anything? Questions on the process? Anything? Anybody? All right. So take advantage of the time. Take advantage of the fact that I'm not hitting you with more stuff, because like I said, they give us these 2-hour blocks, but I try not to overwhelm you with a bunch of information. So if any questions come up over the weekend, something you want, and you don't want to wait until next class, feel free to shoot me that email. Because as a matter of fact, yeah, because this is our last day. So we got Thursday and Friday, not just the weekend that I won't see you. So feel free to email me if you have a question or any problems or just questions on anything. And I'll be looking out for them. Any questions or concerns before we close? I know somebody had sent me an email, I think while we were in class, asking about recordings. I do record the lessons and I will send them out. I'll try to get them out, tomorrow, but most definitely around Friday, because Friday is the day that I really have off. I don't really have Thursdays off because I have other classes at other places and everything. But Friday, I do try to get those out to you. Anything before we close? Everybody good? All right. So you guys know what you got to do. So get on it and let me know if you have any issues. And I'll do whatever I can to help you out. See somebody in the chat. Yep, no problem. Thank you. All right. See you guys next week, Monday. Have a great weekend and be safe.
Thank you.
Thank you.
Have a nice one.
All right. Take care.
Thank you. See
Thank
you
you.
Monday.
Bye bye.